Good evening, sir.
Hey, how you doing? Taj.
Here, sir. Just doing example 4 from the last class. Yeah,
Okay.
mhm. So I'm caught up in a sense. Just need to finish that last example.
All right, yeah, good. So can work on it. We can go through those two examples before we move into this Lagrange multipliers.
Oh, okay. So, new
All
topic
right.
today, sir.
New topic today, because I'm done
Oh,
with that one from last class. We're just gonna do the
mm-hmm.
two questions and then we'll move on.
Oh, okay. All right, no problem.
Cool.
Um,
Good afternoon, sir, and everyone, and Tajay.
Good afternoon.
Hey, Mary, how you doing?
Pretty good, sir, and you?
Giving thanks. You were able to do the two questions?
Yes, sir.
All right. All right. So look at those. Tashi is at number 4. So come to you. Go and read through this Lagrange multiplier for me, Shamari, and then moving to a new topic today. Sajay, finish now?
Not exactly, sir. But you can continue.
No, man. How far are you?
Let me see here. Kind of make a mistake when I was doing, we call it, the FX, the FY and FZ. So kind of start over a bit. So I'm just doing the corrections them. So I'm at FXY and FYX right now.
4 more minutes. At 5:30, we're gonna move in.
Okay, sir.
All right. So let us have a conversation now. Taj, I don't hear gunfire out of you, so I know that you're still working. But let
Yes,
us
sir.
go.
Yes, sir.
Let
Continue.
us, yeah, let us go. What did you get for question 3, Taj? Since you did question 3, what did you get for question 3?
For example, 3, let me see here. For H, subscript F, I guess,
Uh-huh.
equal 0, 8, and then 8 and 8.
0, 8, 8, and another 8.
Yes, sir.
Okay. Shamara, what you got?
For the first over question, sir,
Yeah, question 3.
I got doing it row by row, 0,
Mm-hmm.
8, then 8 and 36.
All right. Yes, that's what it is. You got 0, 8, 8, and another 8. That other 8 supposed to be 36, Taj.
Oh, okay. I
Look
see.
at, I'm projecting it. Look at it, please.
Um,
I give you 2 seconds. Give me a minute, please.
oh, I see. I see what I did. I rearrange where the 0 is. I supposed to put 2. And when, okay, I see what I did. All right.
Evening, sir. Yes, sir.
I think he stepped away for a minute.
Oh. Hey,
Mm.
go through the assignment, the homework.
Yeah, it's in my go through right now. So example 3 and then 4.
You remember to do it, Just remember about it.
Just do it like an hour ago. Yes.
All right.
Sorry, somebody was calling me. Who was that?
It was me, sir.
Yeah, walk on.
There, man. Sir, I need remember not about your homework.
Well, you have to do that out of class because I'm moving into something new now.
All right.
Cool. All right. So, Shamara, you're the only one now that would have done and completed question 4. What you got for the answer?
I got for the first row 0, 7, 0, then 7, -2, -6, then 0, -6, 0.
All right, very good, Shamari. I'll just project the answers right there. 0, 7, 0, 7, -2, -6, and 0, -6, 0. So what I'll do for the rest of you, I will just project the partials for the 3 by 3, and then you can screenshot or whatever it is, and then just look at it. Taj, I want you to find out exactly where you went wrong, and then let me know. Give me half a second,
Oh,
please.
okay, sir.
Sorry about that. I got a work call. All right. Do you see where?
Yes, sir. I saw where I went wrong. Where I have the where I have the negative 2x squared y z.
So which of them?
Let me see. In the question itself, the equation for the beginning. So I spaced it too much and I didn't include the YZ when I was doing like F
Right here.
subscript didn't include it.
Right here.
So hear me, sir? Hello?
You hearing me? You hearing
Oh
me?
yeah, I'm hearing.
I'm
Yeah,
asking if
so
it's right here. So right here too.
yeah, right there, so sir. So I spaced it too much, you know.
Mhm.
So I overlooked it. So when I was trying to get the X and the Y now, I'm like, why it's not adding up?
Mhm.
Yeah, so I had to go back and I realized that I didn't include it. Yeah, so that's why I
That's
started
no
over.
problem. No problem. Very good, Shamari. I'm really proud of you. Keep it up this way, and you should be good to go. Okay, guys. Not spending any more time on that. We started and completed that topic on Friday. Make sure that the recording went out so that you could have the weekend to look at it. So it was sent out early, very early Saturday morning. So we're on to a new topic. I only recognize on my way home today that technically next week is the final teaching week. It's like a no, but it just sneak up on you. And then I said to myself, oh dear. So what I have to do must be done between this week and next week. I really honestly don't want to call it in within that last week. I want you to be able to use that last week for your own revision. For your own stuff. No. If when next week this time comes and I recognize that I don't finish, I may beg you for a day. All right? Within that week. But really and truly, my intention is really to give you that 1 week for yourself to do your stuff. Now, here what is also true. If for argument's sake, you guys decide that you want to do a past paper session or a study session, and you're not too confident with the question or whatever it is, give me ample notice and I can easily join your session. Right? But really and truly, I want you guys to be able to use your 1 week session for your own preparation. For your own preparation to just solidify some stuff, and you should be good to go. All right, with that said, recognizing that we don't have much time, I mean, I should be able to finish this by Wednesday. And on Friday, I will start and finish. Well, I'll have more time than that. Because I mean, the last topic that I have on paper is not going to be more than an hour long. So I could use maybe the other 2 hours on Friday, God's willing, to just touch up any other little area. So I may or may not need that extra week because I still going to have 1 week for myself. That week I can do some revision, whatever the situation is. But let's go. Lagrange multipliers. Again, this topic is one on multivariable functions. I have one other topic to do with multivariable functions. So I'm killing you with multivariable functions. If that's what you want to say, I have no problem. I can't complain about it. So in this section, we're going to take a look at another way of optimizing a function. The one way that we used to optimize a function was our stationary point of the multivariable function. So, but this one is going to be subject to a given constraint or constraints, right? The constraint or the constraints may be the equation or the equations that describe the boundary of the region. Although in this section, we will not concentrate on those types of problems. since method just requires a general constraint and does not really care whether the constraints came from. So let us get things set up. We want to optimize, meaning when I talk about optimization, is really finding the maximum and minimum value. So if I tell you now that optimization is finding the maximum and minimum value, would you agree with me that we did some optimization questions before?
Yes, sir.
Yes, sir.
Okay. Okay. So all right. So what we're looking at now would be questions on the same f of x, y, z, and it could be subject to a constraint g of x, y, z, which is equal to k. So again, the constraint may be the equation that describes the boundary of a region, or it may not. The process is actually fairly simple, although the work can still be overwhelming at times. And I am going to be very frank and honest with you. The topic is not difficult. The truth of the matter is we can start this and done this now. We can start it and finish it now. And I'm not being mouthy at that. It can start and finish. You saw short the question is? The question is to find the maximum and minimum of f of xy, which is equal to f of x, which is equal to 5x minus 3y. And the constraint is going to be x squared plus y squared, which is equal to 136. Right? Right? So it's not going to, it's going to be, so we know what the constraint is. 136. So let us look at the solution. And I want to work with it. I don't want to write. I just want to work with me because I'm going to go through this thing step by step. I'm just trying to bigify it so that it fills up your screen. You can see exactly what is happening. All right. So let's go with the question again. It says to find the maximum and minimum. Rockstone. They are telling you that there's a maximum and minimum. It says find the maximum and minimum of f of xy, which is equal to 5x minus 3y. And it is subjected to the constraint x squared plus y squared equals 136. Let us look at how we're going to solve this. Not difficult. I think I prepared like about 2 or no more than 3 questions for you. I'll go through this one, then I'll give you one to do for you on your own. And after that, the topic finish. Really and truly, there's not much to it. Let's go. So what I'm doing is looking at my function f of xy, and it says 5x minus 3y. 5x minus 3y. All right? 5x minus 3y. Now, what I'm going to be doing, this function is going to be subject to this constraint. So this constraint will have to be in regards to the function itself. Now look at what teacher is doing. Don't blink. Students, I beg of you, tonight is not the time to multitask. Work with me because I'm going to point out some stuff. I don't have time to make a self-discover. I really want to give it that 1 week. Work with me. 5x minus 3y, subject to the constraint, x squared plus y squared equals 136. I'm going to differentiate 5x. So I differentiate 5x, so I get
5.
C right here, so 5. When I differentiate 2x, so I get
4.
Sorry, you mean when you differentiate x squared, you get
Lord
4.
Jesus, you know, see what happened to me? Me differentiated something and I asked you to differentiate something.
Yeah, and
But-
that's
but-
why Shamar answered
That,
2.
and Shama, me say Shama, swim cute, you know. Him not correct me like you know, ask the nail. He might give me the answer now. So when I tell you, say, no, Shama, but sir, that's what you asked me. Me say proper, you see? Me say little boy proper. And you're very nice. You're correct, Shamaria. And yes, I didn't make a mistake. So when you differentiate x squared, where you get?
2x.
2x.
Okay.
All right, good. You see, because this is a constraint, I'm going to put the variable alpha. So it's going to be lambda, lambda, not alpha, lambda. So it's going to be 2 lambda x. It's a constraint. So when I differentiate x squared, I'm going to get 2x. 2x, but I'm going to put the constraint in there. So lambda is going to be my constraint here, right? So, and then now, when I differentiate negative 3y, what am I get?
Minus
Negative
3.
Negative 3.
Negative 3, very good, negative 3. And then now when we differentiate y squared, we get
2y, sir.
2y. But because this is a constraint that we have my lambda, so again get 2 lambda y. Then, sir, you're going to write 2y lambda, same difference. But I'm going to show you is a point I'm trying to bring across, all right? And then now I'm going to write
We can write lambda 2y.
whichever way around, because 2 is multiplied by lambda, which is multiplied by y. So it mean not to me, as long as I have the lambda in there to show that there's a constraint. All right? And then I'm going to have my x squared plus y squared equals 136, which is my full constraint. So you see what it is that I've done? I've now tied this multivariable function to my constraint. Talk truth.
Yes, sir.
All right. Maybe Astonil don't know this, but maybe she does. Maybe one of the guys don't know it either, but maybe you do. So some people, you know, I be a little house to themselves, them get piece of land, you know, them buy piece of land or them get piece of land that is inherited. And this inherited land, well, actually, them have no whole money for go build a big house one time. So the man them a build little by little. So the man them say the plan. Them have them blueprint, and them say, oh, we're gonna start with the living room, and then we're gonna build right around the living room. So we're gonna build one big shell, and then we're gonna use curtain to separate the something. Oh, yeah, we use the bathroom. Is that right, man? We have an outside bathroom right there. So we can go and use that coming on the money for put on the bathroom. We're just gonna put on the 4 walls them. We're gonna put in the flooring and we're gonna put on some temporary roof on the something. We soon do that. So we're gonna make it for now. But guess what? What the man them gonna do is leave out a steel or two, talk truth.
Yes, sir. Potential building.
Yeah. So they're gonna leave out a steel or two so that when they're gonna do the extension, them can tie the steel of the existing building to the steel of the new building. And so them do it, you know. Because if them do it so, when the place finish, the building them gonna separate and one building can drop down on the other. So when they tie one building into the next building, it gives the new building strength. So the house becomes stronger. So if you have an earthquake, remember say you tie the wall already. So you lick out piece of the wall and look for the steel and you tie it to the existing building. So this thing I get some strength. So earthquake come, wind come, storm come, and the house still stand up strong. This is exactly what we're doing. We're tying this piece into this so you can't get rid of it, as opposed to be working with a constraint in and of itself. All right. So that's what it is that we're doing. All right, let's go. So now, I want you to recognize that lambda is going to be the Lagrange multiplier because you're doing multipliers. So this here is going to be my constraint, the Lagrange multiplier. So I have my 3 equations. Sir, how did you get the equations again? That x here is going to be differentiated and going to be equal to the differential of this x right here. So the y going to be differentiated. That's one equation. Of course, including my lambda, which is my multiplier, Lagrange multiplier. And then of course, I'm going to be differentiating my y term. And it's going to be equal to the differential of this term with my multiplier inside of it. And then I'm going to include the constraint itself, x squared plus y squared is equal to 136. So we're going to investigate the differentials now. Remember, lambda cannot be equal to 0. Why, sir? If we are going to be using the lambda as a Lagrange multiplier, it can't equal 0. Because if it equals 0, that means the question done from the start it. right? So it can't be equal to 0. So we're going to solve the first two equations for x and y, respectively. We solve these two equations for x and y, respectively. Now, so as Daniel, I was saying to you, it really don't matter how when we put lambda. Lambda 2, I wouldn't put lambda 2 because normally when you're writing the stuff, the numeral is placed before the variable. True or false?
True, sir.
Yeah, man. So when I write x7, Lobo, one of that want. Right? But we I write 7x. All right? We write 7x. So we need to find to solve the equations for x and y. For x and y. Now look at this. I want x to be the subject of the formula. We're going to divide both sides by 2 lambda, don't it?
Yes, sir.
Yes, sir.
Mm-hmm. I want to work with me now, so I want to unmute and talk to me now, so I want to make sure that you're following. So x is going to be equal to 5 over 2 lambda. And y going to be equal to negative 3 over 2 lambda, don't?
Yes, sir.
Yes, sir.
So my constraint here, the value I get for x, I'm going to square it. The value I get for y, I'm going to square it. Let us check it. See there, as I told you, lambda can be equal to 0. If lambda equals to 0, that means this one is undefined. Same one here, lambda equals to 0 is undefined. Then now, as I told you, I'm going to plug these into my constraint x squared plus y squared equals to 136. So I'm going to have 5 over 2 lambda squared plus negative 3 over 2 lambda squared equals to 136. Tell me that to follow me so far.
Yep.
So far, sir.
Good. 2.
Yes, sir.
3.
Yes, sir.
Okay. 4. We're not here the 5th one, but let's go. All right. So now we need to work out this. So this is not even calculus. No matter of fact, nothing that we've done here is calculus. Yeah, we need the differentiation, which is calculus. And then we pause the calculus now, we're going to do some algebra. So 5 over 2 lambda is the same thing as 5 over 2 lambda times 5 over 2 lambda. 5 times 5 is 25, and 2 lambda times 2 lambda is going to be 4 lambda squared. Negative 3 times 3 is going to be positive 9 over the same thing as 4 lambda squared. See? 5 over 2 lambda square, it means that it multiplies itself 2 times. Negative 3 over 2 lambda is the same thing as negative 3 over 2 lambda times negative 3 over 2 lambda is equal to 136. Algebra still. 5 times 5 is 25. 2 lambda times 2 lambda is 2 times 2 is 4, and lambda times lambda is lambda squared. The same thing obtains for the denominator, so you get back the same 4 lambda squared. When I multiply two negative numbers, I get a positive number. So negative 3 times negative 3 is really a positive 9. So far, I have this. No, if I have 2 fractions, I go one character a single fraction, you know. And besides, the 2 denominators are the same. So all I have to do is add the numerator and put at the denominator. So 25 plus 9 is the same thing as 29 plus 5. So that will look like 34 to me. So we're going to have 34 over 4 lambda equals to 136. See? 34 over 4 lambda squared. I left off the squared. Over 4 lambda squared is equal to 136. Do you agree that the 136 is the same thing as 136 over 1?
Yes, sir.
Yes, sir.
Good. Do you also agree with this 34 over lambda over 4 lambda squared? Everybody saw I get that?
Agree.
If you don't see it, just say so now so we can do it for you.
I understand, sir.
Is it a 36 over what? Lambda square? Or the
No,
30?
36 over 1 is the same thing as 136. What I was asking is, do you see how I added 25 over 4 lambda squared plus 9 over 4 lambda squared to give me 34 over 4 lambda squared?
Yes.
So I'm saying to you, see it here in the recall, when the denominators are the same, simply add the numerators and put back the denominator. So the denominator is 4 lambda squared. So you try to say, boom, 4 lambda squared. And 25 plus 9 is 34. So I'm going to get 34 over 4 lambda squared equals to 136. Work with me now. We have two fractions separated by an equal sign with one variable inside it, middle cross multiply. Talk through.
Repeat that, sir.
Two fractions separated by an equal sign. What do I do?
Cross multiply.
Yeah.
Cross multiply. So that's why I put this 136 over 1. So 34 times 1 is 34. And 4 lambda squared times 136 is enough. All right? So I'm going to get 34 is equal to 544 lambda squared. Follow me?
Yes, sir.
Yes, sir.
All right, good. Now, my aim,
Wait, run that again?
I'm cross multiplying 34 times 1,
Okay.
34. 4 lambda squared times 136 is 544 lambda squared. Follow me?
So far, sir.
Yeah.
Very nice. Now, I have an equation in one unknown, and my unknown is lambda squared. So it only means that I'm dividing through both sides by 544 because my aim is to find lambda squared. So dividing through by 544, I'm going to be left with lambda squared on this side, and I'm going to have 34 over 544. So I'm going to end up with 1 over 16. So lambda squared is going to be 1 over 16 because 34 can go into 544 16 times. 34 into itself was 1 time. Look at this and tell me that you agree with lambda squared equals to 1 over 16 for me so far.
Question,
Yes, sir, I
sir.
agree.
Good job. Thanks, Simon. Go ahead, Asunil.
So lambda square, right? Is it not possible for us to find one lambda? We have
One.
lambda square, which is 2, right?
Yeah, man, we don't finish yet.
Okay.
I'm going to pause because I want you guys to make sure that you're up to date with what I have on the screen so far. Yeah, man, the question, remember I tell you now, the question is not difficult, it's just tedious because there's lots of calculation you have to do, but it's not a difficult topic. It's not a difficult topic, but it is just very long. Let's go. So as Astonel asked, I can find the value of lambda by taking the square root of both sides. So lambda now is going to be equal to plus or minus 1/4. I paused there because I wanted to also to recognize that when I'm taking the square root of a number, I take both the positive root as well as a negative root. When I take the square root of a number, I take the positive root as well as a negative root. When I take the square root of a number, I take the positive root as well as the negative root. Positive root as well as the negative root. So therefore, when I find the square root of lambda squared, I'm going to also find the square root of 1 over 16. And 1 over 16 is the same thing as 1/4. But I have to take the positive root and a negative root. So it's negative 1/4, and or positive 1/4. So first, right, I put a notation here to say that now that we have the values of lambda, we can find the points that will be potential maximums or minimums. All right, and or minimums. So the first one I'm going to be using is when lambda equals 1/4. All it means is that I'm just going to resubstitute. All it means is that I'm going to resubstitute. Sir, where are you going to resubstitute? Thank you for asking. Remember, my lambda was 5 over 2x. My x was equal to 5 over 2 lambda. And my y was equal to negative 3 over 2 lambda. Can you see that? Can you agree with that?
Yes, sir,
Yes,
can agree.
Anybody remember this up top in the question?
Yeah.
So I didn't want to scroll back up, so that's why I recall it right here. So if lambda is equals to a quarter, look at what I'm going to be doing. I want to find the value of x. So lambda is going to be 5 over 2 times a quarter. 2 times a quarter is a half. And 5 divided by a half is 10. Put this on your calculator for me, please, and tell me that you agree with 5 divided by 2 times a quarter equals 10. Quick and fast.
Yes, sir, agree. 10.
Okay. Anybody else?
I agree,
Yes, sir, I agree.
Okay. Now, try this one for me, please. -3 over 2 lambda and tell me if you get -6.
Yes, sir, I got -6.
The rest of you?
Sir.
Okay.
Yes,
Others?
sir, I agree.
Sir, how do I put that into the calculator?
Which of them?
Both of them. So the
5?
5.
5 divided by, not the ABC, the division button. 5 divided by 2, open bracket, 1, ABC 4, close bracket, equal.
Okay.
You got a 10?
Yes, sir.
Good job. And of course, you can do the other one, -3 divided by the division button, divided by 2, open bracket, 1, ABC 4, close bracket, equal.
Okay, sir, thanks.
Good job. Ouch. All right. Do you recognize what I put over here, sir? My x value is 10, and my corresponding y value is going to be -6. So I have 10, -6. So that was my first point. My second point is when x is equal to, I keep calling it x, is when lambda is equal to -1/4. Is when lambda is equal to -1/4. So again, I'm going to recall what the x is and what y is equal to. And I'm going to substitute -1/4 into the said functions, x and y. Go ahead and calculate for x and y, please, and tell me the coordinate. Let me see if you understand how to use your calculators. Quick and fast.
-10 and +6.
Tell me if she's correct.
Is correct, sir.
Thank you, Simon. Anybody agrees with Simon and asking him?
Yes, sir, I agree.
Okay.
Agree, sir.
I agree as well. 10 and -6. Final part. And I want you to listen to this carefully. So I want to think of these as critical points. They are not. They are not. However, just have a slight thought of it being critical points. They are not critical points. Do not write on the paper critical points or critical values. You can get marked out. They are not critical points. Similar to what we have studied into single and multivariable functions previously. No. To determine if we have maximums or minimums, we just need to plug these into the function. Watch me. Watch me carefully. We have +10, -6. Well, I did a negative 10, positive 6 first. What's the value of x?
Negative 10, sir.
Negative
But
10.
so very nice. So I'm substituting 5 times negative 10 minus 3 times 6. I get a negative 68. It's minimum. But sir, normally when we're doing critical points and we get a negative value as a maximum, they are not
Oh,
critical.
yeah. Okay.
They are not critical points. Let me say that slowly. They are not critical points. I know, I am aware, I also agree with you that by the general rule, if we get a negative value, it is a maximum. If we get a positive value, it is a minimum. We know this. And for multivariable functions, if the value is going to be negative, if D is negative, you're going to have a saddle point. We know this. If D is equal to 0, the question can't be solved. I hear a deep sigh a while ago. Who is that? All right, nobody. So, and also, please do not make the mistake when you're doing your multivariable functions, stationary points, for your multivariable functions, you apply this methodology to it. Critical point versus non-critical point. Critical point, general rule, if it is negative, it is a maximum. If it is positive, it is a minimum. We substitute our values just now into a given multivariable function, and we got the value here to be negative 68. We are calling it a minimum. In another topic, we would have said that this is a maximum, but because we're not doing critical points, watch me now. We have a minimum at negative 10,6. Do me a favor. Evaluate the function for me at the point positive 10,6. Remember, I got 2 points, negative 10,6 and positive 10,6, negative 6. Evaluate the function at that point for me and tell me what you get. Let me see if you're following what is happening. Evaluate the function at that point and tell me what you get, and classify it. Classify it whether or not it's a maximum or a minimum value. And then I'm going to explain something to you after.
We are 68 at a maximum.
Positive 60 AM.
Positive 68.
You got a maximum?
Yeah, maximum.
Yes, sir.
Oh, and you got a positive value there?
Yes, sir. Positive 68.
You got a positive 68. Okay. Good. I also got a maximum. Very nice. So, remember, it's when me go school teaching all them niceties to me, you know. And when I wrote this stuff, I was like, why am I being so nice to these students? But anyhow, you promised me some A's. So remember, these are not critical points. So the negative value is indicating a minimum, while the positive value is going to be indicating a maximum value. If these were critical points, the reverse would hold true. We excluded lambda equals 0 because it would not solve one or more of the equations. Do not always expect this to happen. Sometimes we will. Sorry, something that's keep popping up on my computer. We'll be able to automatically exclude a value of lambda and sometimes you'll not be able to do so. All right? So please remember that we're not doing it. Look at what is happening here. Question done. I'm ready for example 2. I'm ready for example 2. Let us look at the question again. And let us talk about the things that we had to do, because the other example is going to be yours. So example 1 is that we first did our differentiation. Look on this, and then we'll look at this one with this one. So we're combining our function with the constraints, and then we're going to look at the constraints in and of itself. So when we do this, we're going to be solving for the value of x in terms of lambda to give us x is equal to this and y to give us to that. And then we're going to substitute it into our constraints. That's the point. We're doing all of this so that we can substitute into our constraints. When we substitute into our constraint, we are going to evaluate it and solve for the value or values of lambda as we would have done there. Solve for the values all the way down, solve for the values of lambda right there. When we solve for the values of lambda, we're going to go back to the value of x and y. See the recall here? And we're going to substitute the value of lambda into this, so it is that we can get the value of x and we can get the value of y. Why, sir? So we can now substitute all of that into our formula, the original function that is. So we get the value of x here, we get the value of y. They look like critical points, but they are not critical points. And then we are going to be working back now with our original function, f of x, y is equal to 5x minus 3y. We substitute. We get a positive value. Positive means maximum. Negative means minimum. You think you catch that?
Yeah, because that's what I initially interpreted it as. That's
All
how
right.
I get that part incorrect.
Do me a favor. I have one there. I want to see how much. I'm not sending you anything. I want to see how much you remember. That's why I said to you. And guess what? When we're going to talk it out in class. When you do the own work, but when you talk about the steps in class, you need to commit the steps to memory. So yeah, it says here now, find the maximum and minimum value of that given function, and the constraint is different. What is the constraint, sir? 4x squared plus y squared is equal to 9. Start from it, please. I'm stepping away from. Go ahead.
So one quick question. Can you scroll back to the first question? We have
Not good at
right.
that, boy.
No. You got too far, sir. We have the 1/4. Can you remember when you get that again?
Oh, I'm finding the square root.
Oh,
I
so
find the square root of x squared.
wait,
So
sir,
it's
say that again.
lambda squared.
Mm-hmm.
So when I find the square root of lambda squared, I'm going to get lambda. And the square root of 1/16, I'm going to get 1/4.
Oh, okay. All right. Yeah, I was
But
confused
remember,
about that part.
but remember, when you take the square root of a number, you take the positive root as well as the negative root.
Okay, sir. All right.
It's not difficult. I promise you. It's merely algebra than anything else. From you do the differentiation in the first part of it, have no more differentiation for them. So which two of them, let me just get a jump start. Which two of these going to be linked together?
The x's and the y.
The x's and the y. Okay. All right. Good answer. All right. Start. All right. I'm coming. Are we okay so far?
Reasoning teacher.
Actually, I think.
All right,
Yes,
good.
that's it. Try things from.
All right, no problem.
Sir, how you write the lambda sign there?
Very sexy.
Sir, so write it, make me sit down. That me a wait on.
I said it. Do the something, no, man.
But
Right the
I
lambda
didn't
sign.
even know how this
Right
come
the lambda
like
sign.
slope, this come back so, and then this come down so. How what this got? All right.
Right the lambda sign. Always stay. When they still a try thing. All right. Let me just make sure that you're not on the right track so far. So tell me the first line that you have.
I was jump out on a ball field.
Mhm.
The first line I have is 162 x equal 8 lambda x. I'm not sure if I'm supposed to still have the x there for the 162.
That's what I had.
That's where I reach.
Like seriously?
Yeah, sir, me have to write out and reason out. What I mean?
Say God no. Say no, you know the other one yet.
I'm about to do the why. Yesterday we must merge the something. Put the something by memory. So I'm gonna have to do that. I'm taking time.
All right. So your first one is the first one for her, correct?
Yeah, sir. I have the same thing, so
You're very distant, Chevoy.
no, I'm saying I have the same thing as well.
Shamari, how you stay, Papa?
We have the same thing, sir.
The rest of one in the class have the same thing as Aston in have?
So far, sir.
Yeah, me can agree with her still though. Me can just make session about the other one. Can somebody just tell me what the other one go?
2y equal to lambda y.
Oh wow, got you. That's that deal. It. She's speaking with attitude. And of course we get the right back for constraint. Very good. So we're on the right track. What's the next step?
Find x and y.
I think the
If
next
that
step is the
if that's you,
fraction
Chevy, if that's you,
where
Chevy,
the
I don't know what happened, but you're very distant.
Oh, find x and y, sir.
you're very
Okay.
wilderness too. That's why you're echo.
Oh, okay.
Okay. Do you think? I'm soon checking again with you. I'm right here. If you need help, just call me. I'm right here. What do you think? I'll just check in intermittently to just make sure that you're not wasting time.
Sorry, you can show back one step. Please. Mr. Shand, are you there?
Sir,
Why Taji laugh? Taji is not funny.
Ain't no funny at all. Else,
I'm
me I
stuck
go
as
on
well.
feet. Yeah, me I go on feet right now, you know.
The boy. I think you need to talk louder so sir can't hear you.
Sir, I'm
Mr.
stuck
Shan.
as well.
Huh?
No, I'm telling you, I'm stuck as well.
Mr. Shand. I don't think he's at the device because I'm not gonna just hear ignore me. Sir. And then you guys moved from where you were? Or where were you?
I'm still at the same place, but you know. Mhm.
Which same place were you? The initial stage?
Europe, you know. I don't have
Okay.
such a good memory, so uh, may the Lord be with me.
What I did after that was the fraction aspect where the 4, because I think we're matching, because we matched the 4 to the 4 to the 81x, right? Or we're matching the y squared. I'm thinking that with the fraction, I'm gonna put the 4 over the 8x. I'm probably wrong, you know, but and then here someone in there, I'm supposed to put the y over the 2 lambda. Because remember, we get 2y equal 2 lambda y. You get what I'm saying? You remember that part there?
Well, not 100%, you know, but let us know it, you know. The pros are here, so let's.
Mr. Professional Mode. Mr. Shan is back.
Sorry, I heard you. I heard the calls, but my hands were dirty and I had to go and properly wash. Okay, what was the question? Forgive me.
Sir will ask.
I can't believe it. Like seriously,
Yeah,
it's
find
like
we on the track, brother.
it's like me carrying a golf and I say, meet me back right here. So I'm gonna go to Florida over there, California.
Stay.
All right, come. Let's go. So you agree to up to that point, right?
Yeah.
Yes, sir.
Okay. So what is the next step?
I'm thinking the fraction aspect.
No man, right here. So what are we trying to do?
Sir,
Interesting.
I was
Cross
trying to
multiply.
find.
So this is where we would cross multiply.
All right, let's just go back to that
Mhm.
stage. When we
I was
got
trying
to
to
when
find.
very
I'll go
good.
back
Yes, I
to
heard that. So when we got to this stage, we're trying to find x. We're trying to find x. Very good. So let us go back down here. Yes, we're trying to find the value of x. Now, let me just pause and show you something here. We're trying to find the value of x. But now you recognize that you can't divide both sides by, well, you have x on either side of the equation, don't?
Yes, sir.
So you have to go say 162x minus 8x, 8 lambda x, and factor out the lambda, factor out the x. So you have to bring all the x's on one side. So you see here, you can have 2y minus 2 lambda y equals 0 because you have y on both sides. Talk truth. And then now you can factor out the y because you want y to be the subject. So you can have y, open bracket, 2 minus 2 lambda.
Yeah, think about that now, sir.
Or, yeah, man, or what you can do, you can factor out the 2y since the 2y is common. Since the 2y is common, you're going to factor out the 2y. Look at that. The 2y is common to both. You have 2y minus 2 lambda y. So you're factoring out the 2y. You're factoring out the 2y. And when I factor out the 2y, we're going to have 2y, and 2y times 1 gives me this 2y, and 2y times lambda is going to give me 2 lambda y, minus 2 lambda y. So this is what happens when I factor it out. I'm trying to make, so several things. So if I have 2y times 1 minus lambda, one of two things. Either 2y equals 0 or 1 minus lambda equals 0. Talk truth. Yes or no?
Yeah.
Good, sir.
If I have 2y times 1 minus lambda equals 0, it's one of two things. We're going to have 2y equals 0, and we're going to also have 1 minus lambda equals 0. And if 2y equals 0, it implies that y is equal to 0, don't?
Yes.
See it here, so? Y equals 0. And 1 minus lambda equals 0 implies that lambda is equals to 1. See it right here, so? Look at this and tell me if you agree with this so far.
Yeah.
So let me just repeat from up here. I start with the second equation first. 2y equals 2 lambda y. I can't divide both sides by y, because if I divide both sides by y, I'm going to get 2 equals 2 lambda. And if I do that, if I get 2 equals 2 lambda, and then I divide both sides by 2, I'm going to get lambda equals 1. But sorry, I have lambda equals 1. Yes, but I'm going to throw away this y equals 0. I'm going to throw away this y equals 0, so you have to be careful. Let me say that again. I have 2y equals 2 lambda y. If I divide both sides by 2y, since I have 2y there, 2y divided by 2y is 1. Talk truth.
Yes. Sir.
Good. And when I divide 2y by here, I'm going to have equals lambda. Don't. So I'm only going to get lambda equals 1. But yes, I have lambda equals 1 right here. But I also have, based on how I did the question, y equals 0. And this y equals 0 is very important, extremely important to the question. So I can't throw out this y equals 0. Can't throw out this y equals 0. All right? Now, there goes my warning. Boy, your teacher love right, you know. Be careful here, not just to divide both sides by y, to simplify, quote unquote, the equation. Remember that you cannot divide by anything unless you know for a fact that it will not ever be 0. In this case, we can see that y clearly can be 0. And if you divide it out to start the solution process, you will miss that solution. Same solution I was talking to you about. This is often one of the biggest mistakes that students make when working these kinds of problems. Please do not do that. Don't just go ahead and just divide all things. You divide all things, you're going to lose it. Let us factorize as opposed to divide out. All right, similarly, we're going to look now when y equals 0. So when y is equal to 0, when y is equal to 0, when y is equal to 0, look at what we're going to have. We're going to have 4. Remember, you know, when we get the values of these, we're substituting to the constraint, right? So when y is equal to 0, we have a constraint, so we're going to end up with 4x squared equals 9, because y is equal to 0. So we're going to get 4x squared equals 9. Now when 4x squared is equal to 9, I can divide both sides by 4. So we have 9 over 4. So we have x squared equals 9 over 4. See there. This goes to 0. So we have 4x. Somebody said something? So I'm going to have 4x squared equals 9. I want to find the value of x squared, or the values of x squared, y values, because this is a square. I want to find the values of x squared, so I'm going to divide both sides by. I'm going to find the square root rather. I'm going to find the square root of x squared. I'm going to get 9 over 4. I'm going to find the square root of 9, I'm going to get 3. I'm going to find the square root of 4, I'm going to get 2. So I'm going to have plus or minus 3 over 2. Look at that and tell me if you agree or disagree.
Agreed.
Mm-hmm.
Agreed. Sir. Yes, sir.
Increaser.
I heard
Sir.
3. Yes, Papa.
So what about the 162x?
Don't reach here yet.
There's another part, that's it.
Mm-hmm. Don't reach here yet. It's just one of them at work. We just work the 2y equal, what was it? We just work the 2y equal 2 lambda. So we have this one up here to work. The same scenario with this one is going to be the same scenario up here. So, all right. So let us see if we can finish off the question. So we know that lambda is going to be equal, x is going to be equal to plus or minus 3 over 2. So we have 2 sets of values. We know that y is equal to 0 from our first set of equation. So we have positive 3 over 2, comma 0, and negative 3 over 2, comma 0. See there? Remember, plus or minus 2, plus or minus 3 over 2 is it being plus 3 over 2 and minus 3 over 2. But we know that one of the values that we got from way up top here is y equals 0. So we have to use this y equals 0 because that's what we started off with when y equals 0. So when y equals 0, that's how we substitute y equals 0 into the function to get the x value. So this y equals 0 is married to the 3 halves, positive or plus or minus 3 halves. Remember, when you're doing simultaneous equations, and we substitute one value in there, that value is married to that one. So that's why we're not doing the 162x at Chevy. We're going to finish off the other equation first. When we get the answer, we'll put it down and then we start with the other one. All right, because we don't want to get the values mixed up. And then now, so the two possibilities obtained will be 3 halves, comma 0, and negative 3 halves, comma 0. Now, that was when we looked at y equals 0, sorry. We now need to look at the constraint lambda equals 1. Lambda equals 1. Right? So we now need to look at the constraint lambda equals 1. We would have used the second equation to work with lambda equals 1. So the only other way we can substitute lambda equals 1 now, Chevy, is to go into our second equation, 162x minus 8 lambda x. Remember, we have two sets of equations. We can't just use one and not use the other. So we have to use this one now, Chevy. So we're going to use this one now to substitute the value of lambda to see what it is that we get. So it's going to be 162x minus 8 lambda x. So 162x minus 8 lambda x, but lambda is 1. So we're going to get 162x is equal to 8x. Now, similar to what it is that we have done before, we are going to be subtracting 8x from both sides so we can factorize and not divide. Matter of fact, if you were to divide out everything here, so you're going to get the x is going to cancel out here, so and the x will cancel out here, so and that now going to make no sense. Now going to make no sense. All right. So I'm going to subtract 8x on both sides. I'm going to have now 162x minus 8 lambda equals 0. Factor out. Not factor out. We're gonna combine because both of them are the same. So I can combine. So 162 minus 8x is going to be 154. 154, good, equals 0. X equals 0. We get x equals 0 right here, so. So when x equals 0, we have our equation here. 4x squared plus y squared equals 9. 4x squared plus y squared equals 9. Remember now, x is equal to 0. So when x equals 0, all I'm going to have is y squared equals 9. And if y squared equals 9, and I find the square root of y squared equals 9, I'm going to get y to be plus or minus 3. But if x equals 0, that means I'm going to have 0, comma, positive 3, and then 0, comma, negative 3. See here? 0, comma, positive 3, and then 0, comma, negative 3. And then that's where we're going to substitute now into our original functions. I don't know which one I started off with. Remember, the original function is f of x is equal to 81x squared plus y squared. So I'm putting 0, 3 first. 0, 3, x is equal to 0, y is equal to 3. All of that goes to 0. 3 squared is equals 9, positive 9. So that's just really, if this positive 9 is a maximum or minimum.
Maximum.
Maximum.
Okay. And if it is, and this one here to be 0, negative 3. Oh, negative 3 squared is going to be the same thing as positive 9. So you say that is a maximum. All right. We're going to have
Maximum.
9. You're going to have 9 and 9. All right. I don't classify them yet. And then now the other set of values now is going to be when it's negative 3 halves, and 0. So the y squared is 0. Negative 3 halves, positive 3 halves squared is going to be 9 over 4. 9 over 4 times 81 is going to be 729 over 4. And this one also going to give me 729 over 4. What is this? Is that a maximum or a minimum?
Maximum.
Maximum. All right.
Yes, sir.
The
Sure,
absolute, go ahead.
sorry, go on.
So the absolute maximum is 729 over 4, which occurs at this point. So both values give maximum, but we want to find a maximum. So if this is 9 and this is 9, 729 over 4 is a bigger value than this one. Talk truth.
Yes, sir.
Yes,
Bigger
sir.
than what?
729 divided by 4 is a bigger value than 9.
Okay. Mm-hmm.
Done.
Yeah.
And of course, the 729 is still a bigger value than this 9. So I'm saying to you that the absolute maximum is going to be 729 over 4. And it occurs at these two values. So what I'm saying to you is, if I got a value here, so this value here, this value here, this value here, this value here, I want my maximums. It says, come on. It says find the maximum and minimum values of that. Do I have any minimum value there?
No, sir.
No, both values are maximum, but guess what? I can't have 9 being maximum and 729 over 9 being maximum. No, one of them is smaller than the other. So it's the bigger of the two I'm going to take. That makes sense?
Yeah.
Yes.
Yes, sir.
Mm-hmm. So for the values that I substitute, the 3,0, the 0,3 and the 0,-3 both gave me a value of 9. When I substituted the 3 halves, 0, and the other 3 halves, 0, I am getting negative, no, I'm getting positive 729 over 4. Positive 729 over 4 is a bigger value than 9. So I cannot consider my 9 being a maximum value anymore. My 724 is going to be my maximum value. So I don't have any minimum value in this one. So it says find the maximum minimum, there's no minimum value. So my absolute maximum value is going to be that. Now, if you look at it here now, based on the values here, this is bigger than the 9. So I am going to say that the values like here, let me just point out something. What did the question ask me for right here? It says to find the maximum and minimum values of this. Based on our calculations, we got 4 sets of positive values. And those 4 sets of positive values, because the values are positive, is going to be that there are maximum values. Look at this statement here. This last statement here, I'm going to show you, is that my absolute minimum value is going to be the 9. Why? Because I'm comparing these two values now, 729 over 4, to be bigger than this 9. But sir, this 9 is not a negative value. Yes, it is not a negative value, but it is a minimum value. It is a smaller value than the 729 over 4. Don't let that make any sense to you. You think it make any sense?
Yeah, makes sense. Couldn't we
Yeah, man.
say then, all right,
Sorry,
even
sorry.
though both, not gonna say points, both values of X and Y had given us, the negative and the positive values had
Mhm.
given us the same responses. Couldn't we then say, for the positive it's 729 over 4 and that would be the maximum, and then for the negative it would be 9? instead of saying absolute?
No, because we never got a negative, we actually got a positive value. So you can't pretend a negative value there.
No, I mean the -3, the at 0, -3, instead of using both values.
No, but remember this 9 occurs at both 0, -3 and 0, +3.
So we couldn't bypass that.
No,
Okay.
because it didn't only occur at 0 and 3. It also occurred at 0, -3.
Okay.
Yeah, man. And that's it. That is it.
So, sir, why did you expect we to get this out of our head?
Because you're calculus 2 students.
Okay. All right.
This morning about 4 o'clock, I got up and started making some notes for you on double integration. I don't finish yet, but I started making some notes for you on it. And I'm hoping to, by next class, finish the double integration so that I can we can just wrap up the stuff.
Sir,
Yes, my love.
you can send us this note, so preferably tonight, please. I can look over.
Do you promise me that you'll be able to look over it tonight?
Yeah. Sir, I have a it again, sir.
What happened? What me do?
They keep class Friday, I never know.
I mean, only keep class Friday, I never know.
I thought you were tired, so I didn't know we're having class.
You thought I was tired? Why would I be tired?
We were having a tired conversation during the day.
Oh yeah. It's
Mhm.
so committed I am.
I must have take some rest. I'm like, okay then.
Yeah, but you see, you tell me to take some rest, the other people them never tell me to take the rest.
Only for pop up and see video. Sir, you know, to do that, you know, you have to tell me when I'm not at class, you have to tell me, say, miss, me keep class.
Yeah, man, the other people them never tell me say, sir, you
Then
must
I realized
fix.
them in their class because they were so caught up in the math. I got the memo.
Yeah, man, them turn up, man.
And I was able to watch the video because I got the memo. Thank you to the person who gave me the memo. Yeah.
So you want me? So you're saying that I'm supposed to feel bad? That's what you're saying?
No, I said nothing like that, sir. Please just send the notes for both the matrix thingy and this one, please. The Hesian matrix. Thank you.
Well, I have to go look up for the other one, but that one is there for you. No. I've sent you the Lagrange multiplier document. So have fun with it. No, hear me out now. I'm almost finished here. I'm hoping that you almost finished too. But I'm seeing that some of you are struggling with the Edicus stuff, and that's why when I was doing the calculus 1, I gave the calculus 2. I opened the calculus 2 so that you guys could start it. Many of you didn't. Many of you didn't. Only Taj and Mikey started and completed those. Now, outside of my calculus 1 students who came over, I know you couldn't start the calculus 2 yet because we're still doing calculus 1. And those students who came over from calculus 1 to join the existing calculus 2 students have completed more assessments than the ones who had access to Educasoft from in January. How shameful. How shameful. The ones who just came over March 1. Not March 1, you know, March 3. One was the Friday, Saturday, Sunday, March 1, 2, 3, March 4. Have completed more assessments than those who had access to January. But remember though, guys, the platform is not going to be open indefinitely. There's going to come a point where the platform closes and you are going to be in problems if it doesn't work the way it's supposed to in your favor. But outside of that, as soon as this one comes up, I will send it off for you. Pick up yourself. You have the notes there for you to help you with the stuff. Please go through and complete the homework. Those of you who never did the homework, congratulations, Shamari, for getting both questions correct. Congratulations, Taj, for almost getting question 1 correct. Have a nice one. We'll talk.
All right, sir. Thanks again.
No
Alright,
problem.
good.
Take care, guys.
Alright.